So today what we're going to talk about are matrices and solving the system of equations using matrices and Gaussian elimination. All right, so let's talk about what a matrix is. So matrices is just plural for matrix. So matrix is a rectangular array of real numbers. So notice that this A sub 1, 1 just means that it's the number is in the first column in the first row. First column, first row. A sub 1, 2 would be the first row, second column. A sub 1, 3 would be the first row, third column. A sub 2, 1 would be the second row, first column. A sub 2, 2 would be the second row, second column. A sub 2, 3 would be the second row, third column. A sub 3, 1 would be third row, first column. And then third row, second column, third row, fourth column. You order a matrix. The order of a matrix is M by N. The M is how many rows you have, and N is the number of columns you have. So this says here, determine the order of the matrix. So look at this matrix here. So I have a 4, 2, 1 going down. How many rows are there? There's 1, 2, 3 rows. So it's a 3 by... And how many columns does it have? It just has one column. 1, 2, 3 rows and one column. So it's a 3 by 2 matrix. All right, let's look at the next one. I have 1, 2 rows. So it's a 2 by. And then how many columns? 1, 2, 3 columns. So it's a 2 by 3 matrix. And the last one, I have 1 row. So it's a 1 by, and how many columns? 1, 2, 3 columns. So it's a 1 by 3 matrix. All right, so let's take a look at the next part here. The next part says how to set up a system of equations. So I have this system of equations here, and there's two different ways to set it up. One is an augmented matrix, and the other one is a coefficient matrix. So an augmented matrix would be set up like this. So you're going to put these bars here. Let me make mine neater. And you're going to put in your coefficients. So I have a 1, -4, 3, and a 5. So it's 1, -4, 3. Now my 5 is what it equals. So I'm going to put a dotted line down and then put a 5. And now that's my first row. My second row is going to be a -1, a 3, -1, -3. So it's -1, 3, -1, -3. And then my last row is going to be 2. Now there's a 0 here, so you have to put in that 0. -4, 6. So it's 2, 0, -4, and 6. Okay, so an augmentive has the coefficients and what it equals. So the coefficient matrix, so you should be able to figure out what that is. The coefficient matrix is when you just have the coefficients, not what it equals. So a coefficient matrix for this one would be 1, -4, 3. A -1, 3, -1, and 2, 0, 4. So this is only coefficients, no equals. Okay, so we're going to be using augmented for now. Okay, so flip it over. Okay, so with matrices, we can do elementary row operations like we were doing before. So you're going to set up the matrix for the system of equations. So I have 0, 1, 3. We're going to do an augmented dotted line, 4. And then -1, 2, 0, 3. And then 2, -3, 4, 1. Okay, try not to write them too close together. You don't want it to look all bunched up, because then when we start, solving and adding and row swapping and stuff like that, you might get confused. So try not to make them too close together. All right, so let's try this. Let's row swap 1, row swap, row 1 and row 2. Okay, so row swap or 1 and row 2. So row 3 is going to stay the same, right? So that's going to be a 2, negative 3, 4, 1. And I'm going to row swap 1 and 2. So it's going to be negative 1, 2, 0, 3, and 0, 1, 3, 4. Okay, now let's do negative 1, row 1. So I want you on the side. You're going to put negative 1 times, and now you're going to put your first row. Negative 1, 2, 0, 3. Just like we did before with Gaussian, right? But you have to actually write the entire equation. So you're just going to write the numbers down. So it's going to be distribute the negative 1. You get 1, negative 2, 0, negative 3. Okay, so that's row 1. So we have 1, negative 2, 0, negative 3. Row 2 stayed the same. And row 3 stayed the same. Okay, I'm just going to move everything up a little bit. Okay, now let's try negative 2, row 1 plus row 3. So I'm going to multiply row 1 by negative 2. So it's going to be negative 2, positive 4, 0, positive 6. And write down row 3. 2, negative 3, 4, 1. Now add them together. So I get 0, 1, 4, 7. So row 1 stayed the same. 1, negative 2, 0, negative 3. Row 2 stayed the same. 0, 1, 3, 4. And now row 3 is 0, 1, 4, 7. So you could see I was actually starting to put this in row echelon form, right? I had a 1 in my first position, a 0 underneath it, and then another 1. I had a 0 here, and I was starting to put it into row echelon form. Okay, so flip it over. Now we're going to actually solve a system of equations using matrices and Gaussian elimination. So flip it over, please. Okay, so solving the system of equations using matrices and Gaussian elimination. So the first thing you're going to do is you're going to write an augmented matrix. So that's the one where you have the equals with it. You're going to use elementary row operations to rewrite the matrix in row echelon form. So what that means is you want to get it to look like this. You want to have a 1 in the first position, a 0, a 1 in the second position, a 0, 0, and a 1 in the third position. Because this is your x, this is your y, and this is your z. They're your coefficients for your numbers. So you want a 1x, a 1y, 1z. So you want a 1, 1, 1 on the diagonal, and all these here have to be 0. All right, then after you get it in row echelon form, you're going to rewrite the matrix as a system of equations. You're going to use back substitution, and you're going to check. All right, so let's start by writing the augmented matrix. So I have 1, negative 2, 3, dotted line, 9. Negative 1, 3, 0, negative 4. Make sure you plug in that 0 for that missing variable. 2, negative 5, 5, 17. All right, so remember, I want my first one to be a 1. That is a 1, so I don't have to do anything to row 1. So now I need, right underneath this 1 here, I need this to be a 0. So I'm going to add row 1 plus row 2 so that I get this to cancel out. So let's write that down. Row 1 plus row 2. So rewrite row 1. That's 1, negative 2, 3, 9. And row 2, negative 1, 3, 0, negative 4. All right, add them together. You get 0. Put the 0 down so we don't forget to write it. 1, 3, 5. So let's write our new matrix. Okay, so our new matrix is going to be row 1 didn't change. Oops, sorry. Okay, so row 1 didn't change, so I have 1, negative 2, 3, 9. Row 2 is now 0, 1, 3, 5. And I keep row 3. So I have a 2, a negative 5, 5, and 17. Okay, so now what we want to do, let's take a look at see what we have first of all. I have a 1 in the first position, I have a 0 below the 1, and I have a 2 still below the 1. So I need to get this 2 to become a 0. So I need to multiply row 1 by negative 2 and then add it to row 3 so that they'll cancel out. So it's negative 2 row 1 plus row 3. So let's write down row 1 times negative 2. So that's negative 2, 4, negative 6, negative 18. And write down row 3, which is 2, negative 5, 5, 17. And together we get 0. Negative 1, negative 1, negative 1. So I have 1, negative 2, 3, 9. 0, 1, 3, 5. My new row 3 is 0, negative 1, negative 1, negative 1. Okay, let's see what we have. I have a 1 in the first position, top left corner, 0, 0, so that's good. I don't care what's here, remember. I have a 1 in the second position for my y, but below my y, I have a negative 1. I have to get rid of that negative 1. So what I could do is, since these are opposites, I can add row 2 to row 3 and get rid of this negative 1. All right, so it's row 2 plus row 3. All right, so row 2 is 0, 1, 3, 5, and row 3 is 0, negative 1, negative 1, negative 1. So I have 0, 0, 2, 4. So I have 1, negative 2, 3, 9, 0, 1, 3, 5, 0, 0, 2, 4. Okay, let's see what we have. I have the 1 here, 0, 0. The 1 here in the middle, 0 below it. That's good. Now I need to get the 2 to become a 1. So I have to multiply row 3 by 1/2. So it's 1/2 row 3. So 1/2, 0, 0, 2, 4. So that's going to be 0, 0, 1, 2. So I have 1, negative 2, 3, 9, 0, 1, 3, 5, 0, 0, 1, and 2. All right, so now I have it in row echelon form. I have a 1, 0, 0, 1, 0, and then my 1. Okay, so now what I want to do is I have to take these numbers that I have left, and now I have to write a system of equations. Remember, this is for my x, this is for my y, this is for my z. X, y, z equals. Y, z equals, y, z equals here. So let's write the system of equation now. So I have 1x negative 2y 3z, and this is your equals 9. Okay, next row. I have a 0 here, and then I have 1y, 3z, and then your equals 5. Okay, and then next I have a 0 here, that's 0x, 0y, so now it's 1z, and your equals 2. Okay, so now you see I have the row echelon form like I was doing before with Gaussian elimination. So now I'm going to use backward substitution. So I'm going to take my z and plug it in right above the equation. So it's y plus 3 times 2 equals 5. So y plus 6 equals 5 minus 6. Y is equal to negative 1. Okay, so now that I have my z is 2, my y is negative 1, I'm going to plug that into the first equation to find x. So it's x minus 2 times y, which is negative 1, plus 3 times z, which is 2, equals 9. X plus 2 plus 6 equals 9. X plus 8 equals 9 minus 8, x is equal to positive 1. So my solution is x is 1, y is negative 1, and z is 2. And then, of course, you have to check and make sure you check original. Always check originals. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.